Hi, everybody. I'm Woody, and I have been waiting to do this particular interview for a very long time because my guest today, if you will, he's really our partner, is Mike Young. And, you know, for me, this interview, I'm going to talk a little bit now, and then I'm going to be not talking, which is really hard for me. Um, I only am into technical diving and rebreathers really because of Mike. So, Mike, it's just amazing. It all happened when I heard you do that first presentation. I think it was at Interspace, and you were talking just about your diving and these crazy holes, right? That you go in. And I was like so nervous because you were like a superstar. And I was like, I wonder if he'll even talk to me. I remember that, right? And not only did you talk to me, you really were just took me in and made me want to get into rebreather diving. And then I met Doug Ebersol, and my very first rebreather was the Kiss Spirit, which, by the way, is perfect. Absolutely to this day. It's just a great rebreather. But then we've come so far, both in the technology and the design, a lot thanks to you. And I just want to get a little bit of a message out there of the way you think. I want you to explain what a rebreather is, why rebreathers, and so forth. So, with that said, we have the amazing Mike Young with us. And my very first thing that I want to do, Mike, my very first thing is two things. One, it's a double part question. One, why did you get into rebreathers? How did you get into it? And what is it? Because I want to talk to a lot of people who are listening to this that have no idea what we keep talking about with a rebreather. Really, we're going to back up. So those two things first.
Okay, I got into rebreathers because I was doing open circuit cave dives at some pretty deep depths, around 90 to 100 meters deep, 280 to 300 feet deep. And one day we had steel 120s plus 10 stage bottles, and I had about $300 worth of helium. This was back in the day too, when you could get a tea bottle for $100. Um, and after the dive, it was all gone. One dive, $300 worth of helium gone. And I was like, well, there has to be a better way. So rebreathers basically recycle the air that you're breathing, whatever the gas mix is. It just recycles it and scrubs out this carbon dioxide and adds back in the amount of oxygen that you need. And so this is a great concept, except as a cave diver, you're never supposed to take a gas past its maximum operating depth. So I had this real issue in my mind of putting a bottle of 100% oxygen on a rebreather and being able to add it to the loop, you know, or well, a computer adding it to the loop at any time. Um, and so I didn't want to go to a full closed circuit rebreather because of that, because I didn't want the 100% oxygen to be able to be added to the rebreather. But there were not really any very good options in semi-closed rebreathers. So I built one.
Well, okay. So a lot of concepts there. So we've got this device. You just explained it. We're breathing and recycling the same gas over and over, and it's adding back the oxygen that we metabolize, but you didn't want the computer to add back in that oxygen. That's kind of what you're saying right now. So that it brings up the next question. So when you said you built one, what did you build? And how was that rebreather then adding the oxygen back if it wasn't happening automatically?
Well, first of all, I didn't know about the KISS concept of a mechanical rebreather. If I'd have known about that, then I would have gone that route. Okay. But I didn't know about that. I'm in a pretty isolated area in the Midwest here. And so diving is not a primary thing. And the internet was just getting started. And so we didn't have this resource of information we have now. So what I did was I built a rebreather that would discharge about 20% of every breath, and it would recycle the rest of it. And then that 20% gets added back in fresh gas each breath. And so, it was semi-closed. There was no, whatever gas you plugged in is what it's going to add. And your metabolism rate when you're never changes. And so if you were shallow, you add in a high nitrox level with a lot of oxygen in it, and it gives you plenty of oxygen. And the deeper you go, then you're using less oxygen, but your body's metabolizing less oxygen. So it was a pretty good system to use.
And this semi-closed, by the way, that's the symbol for it. Let's go semi-closed. Um, how much of a gas extender was that? In other words, how many breaths would you get in the rebreather mode of a semi-closed before you
Yeah.
exhaled and then had to add in more gas?
Well, my original one was 5-to-1. It would make my
Oh,
gas last 5 times longer. I eventually weaned it on down to where I could do about 12-to-1 ratio. But it was getting bordering on not adding enough oxygen and so I couldn't go much more than that.
okay, perfect. So then you said, knowing you, there still has to be a better way, right?
Well, not really.
Oh,
The next step was kind of a series of coincidences. I was building these semi-closed rebreathers for our exploration team, and Brent Hemphill came to me and said, "You need to market those. You need to go into production and produce them and market them." And I said, "No, I really don't want to be in the industry. Building rebreathers, for myself is one thing, but I don't really want to be in the industry. And so he made an appointment for me to meet with Kim of Kiss Rebreathers, and so I met with Kim, and I ended up selling her the patent to my semi-closed, with the condition that I would go to work for her and help her develop new rebreathers.
well,
So
when
that's
you
how I
went,
got into the closed circuit side.
got you. Well, when you went to work with her, why did she need you to develop new rebreathers? Did they already have a rebreather?
Yes, Kiss Rebreather was already doing the classic and the sport, and but they had been producing those for I don't know, 8 to 10 years, with no. When Kim's husband passed away, he was the brains behind the design, and so there was no innovating and upgrading and making the product better. And so she wanted to try to improve the models that she already had, and bring out a new model.
Well, then what in your mind did you say, this is what I think we need to do for the next model, and why? What did you invent?
Well, then that's when the Spirit came out. That's when I designed the Spirit, and I designed it primarily. Everything up until then was most rebreathers had either the counter lungs are on the chest, or they were on the back. And Kiss had the Kiss Classic, which had the counter lungs on the back, and I really hated that. It didn't breathe very well, unless you were slightly heads up. But people dealt with it because that's all they had, and that was the best there was. So I wanted to design a rebreather built around counter lung placement, and so that's how we came up with a Spirit with the counter lungs that actually wrap around your torso, and you have the better work of breathing.
How did you know? I mean, what did you do to test that? Like I'm just, you're starting with a blank slate of redesigning rebreathers to put the counter lugs in a different place. Just walk me a little bit. I'm just intrigued by this. What did you do? Like,
Uh,
here's,
I
here's,
just I,
yeah.
I just visualize it. I can see it. I can see it. I'm like, this will work. This won't work. And I visualized it, and then I built it, and it worked.
So was the Kiss Spirit just one version and that one was the one, or did you have to go through a number of iterations?
Um, we went through a few iterations, but mainly it was on the machining side, how to build it, how to build it more efficiently. The primary concept worked really well. It was just now how do we build them in production model?
And that was my first rebreather, was the Kiss Spirit, and I didn't know any better in terms of good worker breathing or bad worker breathing, and it breathed great. Just so you know, to this day, no matter
Yeah,
what, it's
you
just
should try a
fine.
bad one.
I really have never tried a bad one. So for years, I kept hearing about it and I would see the numbers that measure the work of breathing, but I'm like, wow, I don't know. Our must be terrible because this breeds great. But then how many years went by with the Kiss Spirit before you designed another rebreather? And why did you design that next rebreather that I want you to talk about, which is the Sidewinder that the world knows about?
Well, in between the Spirit and the Sidewinder was the Sidekick, and we were
Oh.
doing some exploration down in Mexico that we needed a side mount rebreather because all of the caves that we were working in were side mount, and so I built the Sidekick, um, which is a rebreather that is completely encased and just goes on your side, and it works, but it's very sensitive to position. If you're not positioned properly, it doesn't breathe as well when you go out of position. But it worked, and we did a lot of exploration on the Sidekick, and so, but then I had a veteran, uh, Josh. He approached me, and he was already technical cave diving and side mount cave diving. He's a veteran, and he had lost both of his legs in combat, and he wanted to get a Sidekick so that he could have a rebreather for side mount cave diving. And I thought about it, and I said, well, Josh, that's not going to work because every time you exhale, the rebreather is going to try to tilt you, and then every time you inhale, it's going to try to drop. I said you'll spend all of your time just trying to keep your balance, and you can't. He swims with his hands. I said you won't be able to swim because you're spending all your time just keeping it balanced. And so I said, but let me give it some thought. I'll see if I can come up with a way of making a balanced rebreather. And so that was the beginning of the Sidewinder. We had to make the counter lung in a balanced location that would breathe well and still keep trim. And so once we designed the counter lung and stuff, and matter of fact, we thought, well, it's going to be adequate. It's going to do the job, and Josh will be able to dive it. But then when I dove the first prototype, I was blown away at how well it actually did work. I thought there were going to be a lot of, you know, issues with it that you just had to live with, but it didn't turn out that way. It turned out to be a really incredible rebreather.
So then after you dove it and you determined, wow, this is an incredible rebreather that I also like, what was your next step to introduce it into the world of rebreathers and the market?
Well, I sent one of the prototypes to Ed Sorensen, and I was supposed to go to the NSS CDS convention, and we were going to show the world, the Sidewinder at this convention. And at the last minute, we had a family crisis, and I couldn't go. So I put it on a mannequin and shipped the whole thing with everything in place on a mannequin to Ed. And he says, well, what am I going to tell people? And I said, well, just don't be afraid to say I don't know, so he went and he showed it and everything. And he called me afterwards. He goes, there's a lot of problems with this. I said, he said, you're going to have to make all these changes. And I said, well, have you dove it yet? And he said, no, but I can tell you that there's going to be problems. And I said, I'm not going to listen to you until you dive it. And so he did dive it and he goes, okay, maybe it wasn't so bad as I thought.
What was he diving a different rebreather before you sent him the Sidewinder?
He was diving a sidekick.
Okay. I didn't know that. Okay, so then he made his suggestions to you, I assume. At what point, just take me through that process. What did you change? What did he think of that he felt like needed to change to ultimately be the Sidewinder one that we all have today? And when did he decide to be kind of really Mr. Sidewinder? I mean, there's no more bigger advocate.
Oh yeah, no, he was awesome. Our biggest challenge on the Sidewinder was not the rebreather itself. It was the harnesses. It was how to put the Sidewinder on 50 different side mount harnesses. I designed it to fit my harness, which fits me, my size. And so when Ed went to put it on, it didn't fit him because he's a different size, you know? And so we had to make different size counter lungs and things like that. But basically the design really stayed the same. The only real challenge for us was how to mount it to this huge variety of and our first attempts at mounting it were, we made like these stainless steel cages to put over it to protect it from getting scratched on the rocks and things like that. And Ed was like, okay, this is just too complicated. We got to get a simpler way of mounting it. And so most all of Ed's input on it was, on how to mount it to all the different harnesses. And it was great because him as an instructor teaching side mount so much, he was privy to seeing all these harnesses coming through all the time, where I wasn't. I would have to go out and buy like 30 different harnesses and, find different size mannequins and try to make it fit. So without Ed, it wouldn't have turned out, it wouldn't have happened as fast as it did.
It's pretty cool. What was the first harness then that he ultimately said, this is the one I think will work best? And what did he implement into that harness to make it work?
Oh man, we're going back in history here.
Oh, yeah, we're going to go
In my
back because it's going to then take us forward.
Yeah, but my memory may not be
That's okay.
my memory may not be accurate. Um, the first harness I put it on was the SM100, the Hollis SM100. And I believe Ed was diving the Ed version of the SM75. And then Ed worked with Hollis to develop the Katana around the Sidewinder. Ed and Nick worked very hard on making the Katana perfect for the Sidewinder. So,
And it really is. I mean, he made all the connection points, where the inside of it to where the counter lungs
yeah,
connect perfectly and line up. So that is to this day what he dives it on. I think it's the katana too. But then other people, I guess, slowly started to see or try the Sidewinder and maybe learned from Ed and then themselves started designing harnesses around it.
yeah. Ed was the primary instructor for probably 2 or 3 years, and most all of the instructors that taught went to Ed, to become, as their IT, and so yeah, it wouldn't have happened without Ed.
And jumping forward, Ed, wasn't he the IT for Patrick, who with X Deep? Did he teach Patrick on the Sidewinder? Patrick
Yes, I
Widman?
I believe they did.
Yeah. So they themselves then used their side mount harness to make all kinds of attachment points for the Sidewinder one. So
Mm-hmm.
there's others. There's, Die Right has one as well. And a lot of other people, as it started to get popular, made harnesses to fit your Sidewinder. Can you believe that thing is so huge? It is the cave diving tool, really, to this day. I'd say it's still the primary preferred cave diving rebreather. Yeah. So then here we are. We've got the Sidewinder one, but then you decided to sell it. The Sidewinder is now owned by X Deep. Am I correct on that?
A subsidiary of XDeep. It's its own little company. But well, I was approached by another company who wanted to have their own brand of rebreather, and since I don't really have anyone that wants to take the company over, they asked me if I would entertain an offer, and I said, "Yeah, that's great. I'll definitely listen, hear you out, and see what your offer is." And so they did a lot of work and third party, look through the books and things like that, and they made me a nice offer, and it was really nice. It was not like an easy decision. So I was thinking about it, and so Patrick Widman and Ed were my biggest distributors of Sidewinder, and so I sought advice from them. I went to them and I said, "Hey, this company made me an offer, and it's a pretty good offer, and I'm thinking about it. What do you guys think, And Ed was like, "I don't think you ought to sell to them." He says, I don't think they'll keep the tradition of the company the way you have." And and then Patrick said, "Give me 24 hours, I'll get you a better offer." And
Wow.
so him and X Deep got together, and they made me a lot better offer. And I also feel that their direction as a company, they'll keep the spirit of Kiss alive, So
When you first sold it to them, was their concept just to take over the Sidewinder one and continue selling and marketing that? Or were they always of the mind to try to make some, if you want to call it enhancements or changes, whichever you want to term it as?
well, they're Piot and Patrick are always looking to improve stuff. I mean, constantly trying to improve stuff. And so in the rebreathers, it's kind of hard because if you make an improvement to it, then you have to do a bunch of testing and things like that. And with, especially with ISO and stuff, or CE, anytime you make changes, it's a big ordeal. And so their idea was, let's make a better version and make the Sidewinder 2. And we know it's going to take a little while to get that made. So in the meantime, we'll keep selling Sidewinder 1s, but let's make it, make a better one while we're at it. And so instead of doing slow improvements one thing at a time, they decided to make, a lot of improvements and make a lot of changes. And it just takes time to do that.
So that ended up creating the Sidewinder 2. Many of us have seen that at various dive conventions that are around the world. But the Sidewinder 2 to this day, because I think it was maybe, I believe it's been at least 2 years, it could be three since I first saw the one that came out, is still not yet, if you will, on the open market. And so two questions. Um, why? And then when will it be? Why isn't it? And when will it be? And then we're going to go
Well,
forward.
you know, they have these grand ideas, and I mean, they're going for, the top of the line, the best of everything when they're building this. And that the manufacturing processes alone, there were a lot of challenges there. And as they overcame these challenges, and moved on to the next one, it just took longer than anyone anticipated. But then once they had a finished product, the CE testing and the paperwork is just a phenomenal amount of work. And I think I think nobody just really understood how much time that was going to take. And so that's why the delay. But I think it'll be worth it in the end because of the value of the product that's being produced, right? So, but I think everyone just kind of underestimated how long this whole process would actually take. And it's one of those things that you have to have this part in place before you can do this part. And then all of these parts have to be in place before you can actually go to testing. And once you go to testing, then the work starts, the paperwork and all that. And so it's just a drawn out process. And any little snag along the way was, months of delay. So, but they're on the finish line. They're actually right there. Almost all of the paperwork is finished. They have production all streamlined and ready. And it's my understanding that within 30 to 60 days, instructors will start receiving their units to get their hours on them, and they'll go out to the public shortly after that, once the instructors start have accumulated their hours to start teaching it. So,
Well, then I can't help but ask, the Sidewinder 1 is hugely accepted in Dove around the world and does not have a CE. Why didn't they take the same path for the Sidewinder 2, where it could have been Dove around the world and widely accepted, and go for a CE? Why not, in the meantime, even if you are going to go for a CE, sell it, let the world dive it, because it's pretty much been
well,
ready?
there's a couple drawbacks to the Sidewinder 1 and the market available to the Sidewinder 1. It's being produced in the United States, and we have regulations because rebreathers are classified as military equipment. And so we have regulations of countries we can't ship to and things like that. And so their idea was to go ahead and be producing the Sidewinder 2 in Europe. And so that's where all the manufacturing is. And then they won't face those regulations on the military side. But the European Union, they can't produce and ship units even inside the European Union without having a CE certification. So it's a double-edged sword. In order to be able to access this massive market, it has to have the CE stamp. So and so the plan was just to go for the CE stamp instantly, before they started producing them.
One more question on this then, and then we're going to move forward, because that's very interesting. If you were to rewind the clock, would you suggest, can still to this moment suggest, that they have gone for the CE for the Sidewinder 2, or would you just have manufactured it here in the US where you are for them?
No, they need to take the route they're taking. I mean,
Got
the market is so much more. I mean, I'm only allowed maybe 20% of the market, and a lot of that, it has restrictions on it and things like that. And so, but I wasn't producing the Rebreather, the Sidewinder 1 in the quantities that they're going to be producing the Sidewinder 2. And they need the bigger market. And I'm just a one-man show here, and I didn't have to have that big a market.
Got it. So then we move forward, and in your mind, always needing to create, what was the next rebreather you created and why?
So, well, I'm always building rebreathers, okay? But they don't always go to market. I've got a shelf
Oh, okay.
with a lot of rebreathers on it, right?
Interesting.
So it was actually Gus who started us down the next path, and he said he wanted to dive every rebreather that I had built. And so he went and trained on the Sidekick and got a Sidekick. And he and then he said, well, what other rebreathers do you have? And I said, well, I have a little chest mount rebreather that I play in the lake with that only runs on oxygen, you know? And he was like, yeah, I want to try that. And so then that's when I carried one down and you and Gus tried them. And then you guys really enjoyed it, you know? Well, that just starts things then. And so, but I never really taken, I've been using this chest mount rebreather for, I don't know, 10 years or so, oxygen only as a toy. I never really took it or viewed it as something that you could be able to produce and sell. And until I was talking to a friend of mine, and he's like, "You're thinking about this completely wrong. Most dive boats don't like rebreather divers because they take up too much room and stuff." He's like, "This rebreather could actually be used by a recreational diver on a recreational boat without causing troubles for the boat captain and things like that, you know." And yet would be you know, a great rebreather for, you know, somebody who uses too much air, for example. And so going that route, then I was like, okay, well, if we convert it, you know, to a diluent oxygen and diluent rebreather, you know, what would I have to do to make that happen? And so that's when we started working on it. And that's when you said, hey, I want to be the one that markets it. And then we named it the Go, so you can grab your gear and go. And so that's what started that evolution.
And I remember when I dove it, saying to you, I already thought I had the most amazing work of breathing rebreather. But in this little go, that it's now we have a rebreather that mounts to my chest on any recreational BC I have. The counter lungs are placed exactly where my lungs are. I'm turning upside down, moving all around. For me, anyway, I was like, it breathes perfect no matter what position I'm in. And it's so easy, my kind of diving. So I loved it. And then at that point, we decided to make a partnership and we private labeled it and we call it the Dive Talk Go. Um, can you show it and talk about what you designed in it in terms of that Go ring and the way the air flows and moves through it to achieve what ended up testing as one of the best work of rebreathers on the market? I want to just start with the work of breathing aspect of it. Can you go through that? What did you do besides just the counter lungs? It's not just a circle that you pour sorb in. It's you thought of much more, and I want them to hear about this.
Well, I don't know if you can see very well.
We can.
Let me angle the camera down a little. So the main thing on designing a rebreather is you always start with the counter lungs. And the counter lungs have to be in a place that will breathe easily, right? And so on the Go here, yeah, we have the unit here, and the counter lung comes up at an angle, okay? So when you're wearing it, the counter lung comes beside your lungs here. So if they're on the same level as your lungs, then it's easy for the gas to change back and forth. Most chest mount rebreathers, the counter lungs are out in front of you, okay? So then you're having to push that gas down into the water, and it comes back really easy, but there's quite a bit of effort to push it down. So that was the start of the chest mount rebreather. The next thing in the design was that we need the scrubber to have a lot of surface area and not a long bed. So my nice clean rebreather here. So what happens is the gas comes into here, and part of it can go into this counter lung, but part of it comes in and comes behind this screen here. And then it goes through the scrubber to the other screen. And in this part, we have oxygen sensors that measure the oxygen, and it goes back out, and then you inhale it. It goes to the other counter lung also, and then you inhale it. So the scrubber bed itself is a large diameter, but it's a real short, so the gas can go through it real easily.
Is the diameter of it the same, or does it get narrower as it goes up? And if so, why did you think of that?
Well, one of the problems when you have a real short bed is you've got the granules stacked in there, and if you have a smooth wall there, it will allow gas to run along that wall easily. Okay, and so you need the granules to be offset some so that you don't get this smooth surface where they can flow real easy. Now, if you had a longer bed, it wouldn't be as much to worry about because eventually the gas is going to move around and not just stay on the walls. So I don't know if we
Yep,
can see that.
we can.
Anyway, so we put ripples along the side here so that the sorb can be off shaped, and it won't be very easy for gas to pass along that bed. So that's one thing that allows us to run a shorter bed without as much fear of breakthrough.
And by breakthrough, what you're saying, just for those that don't understand, is that the gas itself would not go inside of it, would not hit the sorb, which removes the carbon dioxide. Therefore, you could get what we call channeling. You would breathe air that never got scrubbed of the CO2.
Correct.
Yes? Okay. So then at that point, did you have to do a number of iterations of the go, or is what you holding still the pretty close to the original design?
It's pretty close. We moved a few things like how the clamps clamp. Originally, we had it with two clamps, and we realized that the material was not strong enough to hold with just two clamps. So we moved to three clamps. Little things like that, little things that just made it easier and better. But the basic premise of how the gas flows and where everything's located remain the same.
Now, you decided, even with the Go and even with the huge advancements in technology we have with the computers and with so many electronic rebreathers out there, still to make this a mechanical rebreather. Why did you still hold on to that? And explain the mechanical rebreather part as inside the Go?
Well, the electronic CCRs, if they're working good, they're working good, right? Everything's great. The potential for them to not work is higher than a mechanical rebreather. The type of diving I do, I try to eliminate as many failure points as I possibly can. The less that can go wrong, the less I have to worry about it. When you cart your gear for 4 or 5 hours in a cave and then you get to the water and something doesn't work, it's very frustrating. And especially all you can do is carry everything back out. And usually you have a team of people to do this, and it is so embarrassing to turn to the team and say, "Hey guys, sorry, all this work was for nothing. We're going to have to come back tomorrow." And so in my diving, I want to keep it as simple as I possibly can. So if you add a computer that runs a solenoid, you're adding all of these other things that can go wrong. Um, not that they go wrong like half the time or anything like that. It's just that they have the potential to not work. And usually it's going to be at the most inappropriate time. It'll be at the worst possible point is when they're going to say, "Oh, I'm going to start leaking." And so that's why I stay away from the electronic rebreathers. It's a personal choice. Okay. So when I go to designing things, I design things that I want to dive. And then if other people want to dive them, then that's great. And I sell some. But most every one of my rebreathers I've ever built was built because this is something I need for an expedition I'm going on. And so, anyway, so that's why I've never jumped over on the electronic side. Mechanical is just simpler. And to me, simple is safer. Okay. So, yeah.
That's a very fair answer. Okay, so then here we have a mechanical rebreather. Explain why the word is not manual rebreather, which I myself have had to be corrected on. What does it mean that it's mechanical? And we have to monitor in rebreathers what is known as the partial pressure of our O2. You'd have to take the class now to learn all about what all that means, but
Yeah.
you have to monitor in a rebreather course. Every page of a manual says, watch your PO2. That's how important this is. So, what's the difference between the manual and mechanical? How does our mechanical rebreather work? How do I add oxygen? Like, why is it mechanical?
Well, even in electronic rebreathers, who are supposed to be the computers controlling the PO2, they train you to continually monitor it yourself to make sure nothing's going wrong. Okay. So we're not saving anything by being mechanical, electronic, by not having to monitor. Okay. Because you have to monitor no matter what. Right. So there's no huge reason for going electronic so that you don't have to monitor. Okay. Now, on an electronic rebreather, a lot of them are trained on flying it manually to, and then let the electronic part just be your safety net, right? And so when they say flying it manually, that means adding oxygen manually to the rebreather to maintain your set PO2 that you want or set point.
And
So
do they add that oxygen by you're indicating that you're pushing a button?
yeah, usually it's a button on the counter lung that they add. You have diluent on one side and oxygen on the other counter lung. And so generally you just add on the oxygen side, and that's called flying it manually.
Okay.
Okay. Our rebreather, and the drawback to that is as your body metabolizes it, you have to continue to add, right? So what Gordon came up with to make it safer was he put an orifice in the KISS rebreathers that flowed a specific amount. And if you match that amount to your metabolic rate, then it's going to constantly flow enough oxygen in to keep you alive, keep you conscious, and keep you at a very stable set point. And then all you have to do is add a little bit occasionally, depending on your workload or if you change depths. Okay. So it takes the adding every 5 minutes and makes it into adding like every 20 minutes. And then it's not a necessity. It's mainly to keep the perfect set point to get your, so you have the best decompression schedule or something to that effect. So by adding that orifice, you increase the safety a lot. And the orifice is completely mechanical. It's not something that can lose its electronic signal. The battery goes dead. It does this, it does that. It's very safe. If it's flowing, it's flowing. Now it could get plugged up, but that's something at the beginning of the dive. It's not usually going to happen during the, it usually happens when it's in storage for too long or something. The orifice gets plugged. So it's not something that is a huge failure point because the orifice is a set size, a set diameter, and it's going to do its job. So
many people have said to me, but Woody, your mechanical rebreather that Mike designed is adding a continuous flow of oxygen to replace the oxygen that you metabolize. But that is a problem when I'm deep. I don't want this mechanical rebreather to even have any possibility of adding oxygen if I'm very deep. Because for those of you that don't know, the deeper you go, the higher automatically is your partial pressure of your O2. So if on top of that, if I'm at 300 feet and it's still adding in the same amount of oxygen, if we exceed a certain PO2 level, you could convulse and die. How did you overcome that potential risk?
Well, your body will metabolize oxygen at rest at the same rate, no matter what depth you're at. Okay. Your at rest metabolic rate is fixed. Your body needs this amount of oxygen per minute to do its function. Okay. If you were to exercise or something, then it would need some more. Okay. But at rest, your body metabolizes X amount of oxygen, and everybody is different. Okay. Mine is around, at rest, is around 0.68 liters per minute. Okay. So if I make that orifice flow exactly 0.68 liters per minute, no matter what depth I'm at, my body is going to consume that oxygen. And that's just that. Okay. As long as you're alive, you're going to be consuming oxygen. And so it should never go up. It should never go higher than that. And so what we've done is we've set this up to where no matter what depth you're at, that orifice flows your metabolic rate.
At what point will that flow of oxygen no longer be able to push against the pressure of the water due to depth?
So that depends on where your pressure is set at, because you change the pressure to change the flow. So if you set the pressure at, say, 150 psi, which is 10 bar, once the water pressure reaches 10 bar, it's going to quit flowing. Okay, which is around 10 bar is at 10 atmospheres, which is 300 feet.
300.
So now it's going to start flowing slightly less that last little bit. And so realistically, around 280 feet, the flow is going to slow down, and it's going to go to, and by the time you get to 300 feet, it'll stop flowing.
So when it stops flowing at that point, to knock out a lot of people's questions on this that I get all the time, they would say, well, now, Woody and Mike, you just told me you're still metabolizing oxygen at 330 feet at the same level. Where are you going to get your oxygen from that you metabolized?
Well, for one thing, your metabolism doesn't change, right? And so if you have a counter lung that has, say, 3 liters, well, you have a whole loop volume, say 5 liters. If you have that, your PO2 set right, on the surface, within about 3 minutes, your PO2 is going to start dropping. Okay. But at 10 atmospheres, you now have 10 times as much because the gas is compressed. Okay. So instead of in 3 minutes, you have to add oxygen, you now have 10 times that. So now in 30 minutes, you have to add oxygen. Okay. So for one thing, there's several ways around the adding oxygen. The safest way is to have an additional oxygen source that is completely independent. Okay. That gives you redundancy also. So.
But most of us, when we dive to go, speaking for myself, don't have a redundant source of oxygen. We have another gas that we bring with us, which we call the diluent gas, which is also our bailout gas. So the diluent means it can bring down our PO2, diluent, dilute, or if we have to get off the rebreather, it's also the gas that we would breathe on open circuit. And we need to bring enough with us, we all know in Rebreathers course, to get us out of the worst possible scenario in a dive. What are we using on your Rebreathers then to add that diluent gas No, because now our oxygen is not flowing anymore at the 300 feet. What do we have on your rebreather to add that gas in? Because you're at 300 feet, everybody. So you really need a very low level of O2.
Well, first, first of all, on mechanical rebreathers, going to 300 feet is not the big issue, not a big issue. Okay, but I really don't recommend you go to 300 feet on the go, because it doesn't have a long enough scrubber duration to do your decompression. Okay.
Great point.
So,
How long of a
so
how
I
long of a
wouldn't
scrub?
exceed 300 feet on the go.
How long, just for everybody's understanding, on the basic go, how long is that scrubber good for? Typically in warm
Depending
water?
on water temperature, workload, everything, 2.5 to 3 hours.
So what would you feel comfortable saying based on the basic go, which you're holding, they could go to and dive that thing to?
I would do 180, 200 feet.
Okay. Okay.
Because once you go there, it's not like you're going to go there and not do anything. You have a reason to go there, right? So you're going to spend 5 to 10 minutes there. It's not like, oh, I'm going to just see how deep I can get and then come right straight back up. You're going to like go to a shipwreck, or you're going to go down to, a reef or something. So you want to spend a little bit of time there too. And so the dive planning needs to not exceed, 2.5 to 3 hours.
And that's all part of what you would learn in the course. But let's say you have to add diluent. How do we add it in your rebreather? What is the next?
So
yeah.
Most rebreathers have an automatic diluent add valve, and it's basically a open circuit second stage regulator. And what it does is, when there's a vacuum on the loop, it adds gas. And so it's really simple. So if you wanted to do a diluent flush and put all fresh gas in of a exactly known PO2, all you have to do is blow gas out your nose instead of your mouth and inhale back in, and the automatic diluent valve will add gas, fresh diluent in.
And that gas is plugged into the rebreather from a hose coming from your back, if you're on a basic back mount open circuit, onto, can you lift it up and show them just how simple it is to connect the gas to the rebreather?
Oh, it's just a simple BC inflator hose.
Connect, and you're done. Okay. So now, and you could also manually do it, right? Doesn't that have what would be?
You could, like any second stage, you can push the purge button. You can purge it and add it.
Okay. And then what are we breathing from? I mean, do we have something in our mouth?
It's magic, Woody.
I don't know if
Yes.
it just comes into my body, or somehow we breathe in and out of this thing.
Okay. So these are the loop hoses. They connect to the rebreather. And on the front here, there's a lever. This is the diver supply valve. Okay. So when it's not in your mouth, like now, the valve is closed. So down is closed, up is open. So once you put it in your mouth, there's a little purge. You can purge the water out of it. And once it starts blowing bubbles, you can open it up. And now you're breathing in the loop.
But you told me that the air flows, that you want the air to flow in one direction going in and another direction coming out. You told us that at the beginning when I asked you, well, what about the flow? Well, it seems to me if you're blowing in and out,
it has to flow one direction, because it has to go through the sorb. And if you're not directing it to flow that way, then
well, how are you making that happen? How are you making that happen? I mean, show me what. It seems to me I'm blowing in and out of a loop. It's just going to go both directions. How did you design this?
Well, it's not my design. I've copied the rest of the world. Everybody does it. Okay. But there's a little mushroom valve in here. Okay. So when you blow out, the little mushroom valve makes it go this way. And there's one on this end that'll only allow gas to come in. It won't allow gas to come out. So it has to go one way and come back the other way.
So with that, those little mushroom valves protecting the way the gas flows, and that diver supply valve, that's what it's called, a diver supply valve, and the unit itself, it seems like it needs some maintenance, right? Or is it just survive on its own forever with never touching it? What are they going to learn basic maintenance wise? What are the things they're going to have to maintain in this unit?
Well, most of it is very simple. It's cleaning the O-rings, lubricating them, and things like that. Just keeping everything running smoothly. But maintenance is really very simple.
It is. It's got O-rings. It's the cleaning. It's taking apart that little DSV, which is very easy to do. I can do it. So that tells you it's very
Yeah.
easy. Okay, so you've designed this. We've sold a bunch of them and so forth. What about the basic training? And really, this goes for any rebreather. Um, if I've already been trained on my KISS Spirit and it's pretty much the same concept, do I need to take a new course for this one? I mean, what do we got to do to get trained on this
Yes.
thing?
When you do, you need to do a crossover course. And it's the basics. It's not going to try to teach you how to dive a rebreather. It's going to teach you how to dive this rebreather, how to pack the scrubber, how to maintain it, what drills are going to be different. If you bail out, is it going to be different than the Spirit? Things like that. And so it just teaches you the difference between. It's not like teaching you how to drive a car. And you get in someone else's car and you can't figure out how to turn the wipers on. You can't figure out all these things. So it's teaching you how to dive this particular rebreather, not rebreathers in general.
Now, I'm very biased, so everybody's going to automatically say that when they hear this, but I actually love simple diving. I do. I really, it's still to this day my favorite diving. And this rebreather is just so simple and small for me. It is my favorite rebreather. I literally can't wait to jump in the water with my go. Not the Sidewinder, not the Spirit, but the go. It's just so simple. What in your mind then, what are you thinking in terms of the next thing to come after this go? That I feel like every time you've given me something, I'm like, this is it. There is nothing left for me to have. I'm in love with this thing. So what's next and why?
Well, there's not really much we can do that would improve the go. And so it is what it is, right? And so but I've got other projects I'm working on where I need other rebreathers. Okay. So currently we're working on a project where the go would not be a very good choice. And so I'm building a back mount rebreather that is going to be the same kind of concept as the go, as to where the counter lungs are at and how that works, except that the unit will be on your back and much larger, where we'll have like an 8-hour runtime.
So if somebody is buying the go, they may say to themselves, I might as well spend a little bit of extra money because the Go is very affordable. It's probably one of the most affordable rebreathers on the market, and get a rebreather that has a longer scrubber duration, because that, you said earlier, that seems to be the limiting factor on the Go. However, you didn't like that. So did you create something else to extend the Go?
Yeah, and I don't know if I have one of those. Yeah, I do have one. Yeah, because me personally, I have a lot of different rebreathers for a lot of different applications, depending on what you're doing. But I can understand people who have one, but they want just a little bit more, and they want to be able to do a little bit longer dives. And so I made this extension ring here. And so basically, you take your go and you add the extension ring to it, and the O-rings are in place, and so it makes it kind of hard. So now we've increased the length of the scrubber bed And so it really it gives us, man, I'm right off the top of my head, I can't remember numbers. I think we can go out to 5 or 6 hours
6
now,
hours.
because we have that much more sorb in it. So
So now we have our go that originally 2.5, maybe 3 hours, possibly going all the way up to 6 hours on this
yeah,
chest mount rebreather. Just so everybody knows, I wanted to be sure they understand. You don't have to go out and buy another rebreather if you only want to take it up
yeah,
to 6 hours. So then what in your mind then, now that the go can go up to 5 to 6 hours, I still hear some hesitation in your voice, out of fairness of this is an impartial, I'm trying to be impartial, as to why you still think the go should be limited to 200 feet. With the extender, would you then be okay with the go being at 100 meters if they took the right amount of gas?
yes, if you took the right amount of bailout, because that now becomes your next limiting factor is okay. And so you're going to have to carry stage bottles. And as long as you're, comfortable doing that, you can definitely clip stage bottles on and still dive the go comfortably. It's just a matter of you're going to have enough bailout gas in case things go wrong. So, but yeah, I mean, I with the extension ring on it, I would definitely dive it to, you know, 300 feet or 100 meters. So,
So, why then did you invent this other one? Is it just because you need even longer? Like in your particular case, because you're an
well,
explorer?
yeah, I needed longer. We're facing a restriction, and it would be better to have the rebreather on our back than it would be on our chest. We're having to scooter through this restriction because it's high flow. The less drag you have on your chest, uh, the better the scooter is going to perform. And so I needed actually what I needed was a back mount go, and so that's what I'm building, a bigger back mount go.
It really is amazing, Mike and world, that he's not kidding. He literally designs these things because he needs a new tool for some other crazy thing you're doing. That's what starts all of these projects. You just said you have a restriction. You're in your mind somewhere. I guess you're getting ready to explore something. That's what created your
Yeah,
next rebreather. Amazing.
yeah, we're pushing some cave where the restriction is super high flow. I'm talking like, 9+ on your sea craft and just barely inching through it, right? And it's at 300 feet deep. And so it's got to breathe really good, and it's got to be, everything's got to be running smooth.
But sort of wrapping up here, for the vast majority of us normal people that I want to jump off of a boat, I want to go down to some of the wrecks in South Florida that are technical, meaning they're below recreational depths. There's some really nice wrecks
Mm-hmm.
at the 2 to 250 range. For me, 3 hours is plenty. That's a long dive. I'm ready to come back to the
Oh yeah.
boat and have a nice lunch. Right? Is the
Yeah. Just
go
put the Go Plus ring on and carry you some bailout decompression gas, and away you go.
and
Smooth and
that's
easy.
it. Yep. So, is there anything else, Mike, in your mind that you want to just wrap this up with, just to tell? We get a lot of people out there that have all kinds of suggestions and comments and want to make this change. They want to protect the counter lungs. They want to change the back plate. They think there's a better way to connect this or that. We get a lot of that. What do you want to say to everybody about all of those things? Because it's not like, wow, I didn't think of that. I mean, you've got a lot of experience here, right? So just a
Yeah.
summary of all of that.
Well, I'll tell you a story about Brent Hemphill. He's a famous cave diver, lots of experience. He would come up with these ideas, and he goes, "Mike, you need to build this," And most of the time, it was stuff that I had already tried. But on one particular occasion, I said, Brent, I've already tried that. It didn't work. He goes, no, it'll work. I can visualize it. It's going to work. And I was like, Brent, it won't work. And I'd explained to him why it wouldn't work. And he's like, no, I really, and I was like, look, I'll send you the parts. You're going to have to just try it before, and then about a week later, he calls me. He says, yeah, that didn't work like I thought it would. So it's not that I didn't think of something, and people are always giving me suggestions, and it's like, you know, but I don't want people to not give me suggestions because there may be things that I didn't think of, so I'm always open to suggestions, but I don't want to hurt your feelings by telling you I already tried that and it didn't work. So,
Yeah, and some of those things, just for everybody to hear the ending here, is Mike's aware that the counter lungs aren't wrapped in a case. He's aware of that. The chances of you punched, go ahead, talk about that one. That's probably the
well,
biggest one we
that
hear.
that particular one is, but they are very protected though, because they're basically under your arms and there's nothing sharp should be getting there, right? I mean, I've taken my go through some gnarly wrecks and I've never cut a counter lung. I've come out where I had like rust stains all over me, that I'm like embarrassed to get back on the boat because they're going to be knowing I was touching stuff, and never had a counter lung cut. We have well over 100 units out there running, and nobody has ever we've never sent out a replacement counter lung. So by covering the counter lungs, you would be trying to find a solution to something that's not really a problem. Okay. And to me, you're adding complexity to things, but I can understand people wanting a cover because there's really no way to personalize the go. And so I'm actually working on a cover for you, Woody, but it'll be a surprise. But I don't know what color it'll be.
Oh,
But
oh my, I already love it.
I'm working on a cover that would allow people to personalize their go. And that way, you can have your own colors, you can put patches on it, you can put your name on it, things like that. I can see the need for that.
Final question. You've said this to me so many times that I wanted to save this to the very, very, very end. For those that are still watching, they get the pleasure of hearing this. You've never told me these words. My rebreathers are way better. You should just dive mine. Don't worry about the others. Instead, you actually said something else. What do you tell people to do when it comes to trying to decide on a rebreather? There's so many out there in the market. What do you, if you're consistent with this advice?
Well,
Do
there are a lot of excellent manufacturers. Okay, there and there's and I have personally, I don't know, probably 20 rebreathers, and the reason is because not every tool is applicable for every job. And so I have different rebreathers for doing different things. And you as a consumer need to realize what you're going to be doing. Okay. The guy that's going and diving the Britannica, for example, versus the guy that's doing a drift dive in Cozumel, completely different applications, completely different tools. There's not a rebreather that would do everything well. Okay. There's rebreathers that'll do one job really well, but they'll get by in other jobs. And so, but my big thing is you need to educate yourself. And the only way to educate yourself on the rebreathers themselves is how they actually dive. If you're interested in 3 or 4 different brands, go and dive those brands. Go and do a pool session. If you still can't decide, do a course. Okay. Because it's better to spend a couple $1,000s on a course than it is to realize halfway through the course that you made a mistake. And now you have a $10,000 rebreather that you're not going to use because, so go out and dive as many different rebreathers as you possibly can dive before you make your choice. And the reason I can say that is because once you dive mine, that's the one you'll choose.
That's what I know that's what's going to happen. Well, thank you so much for this. And I know people can actually this hopefully this video will endure. So I'm not asking you to talk about specific try go sessions that you're having, but you are having them. If people are interested to know about our next try go session, just reach out. And you can get much more information about this at divetalkgo.com. And thank you, Mike, for helping change the dive world for the better. You keep innovating. No idea what's coming next, but I love the go.